All right, this lesson is on proving that triangles are similar. So if you remember back in chapter 4, we proved that triangles were congruent. And now our thought process will be very similar, but we're not proving that triangles are congruent. We're proving that triangles are similar. So our thinking needs to be a little bit different. But we're going to use a lot of arguments and ideas and theorems that will sound very similar. So for example, Theorem 8.2 is what's known as SSS similarity. So if you remember, we had SSS congruency, and that said if all three sides of two triangles are congruent, then we know the triangles are congruent. This is SSS similarity, which says this: if the lengths of the corresponding sides of two triangles are proportional, then we know the two triangles are similar. So if we call this triangle ABC and this triangle DEF, then if we know that the relationship between AB and DE is the same as the relationship between AC and DF is the same as the relationship between BC and EF, if we know all of those proportions work, all of those ratios work and are the same, then we can say that we know these two triangles are similar. All right? So moving on, we also know SAS similarity, which is exactly as it sounds. If one angle of a triangle is congruent to an angle of the second triangle, so if we know both of these are right, which means they're congruent, and then the lengths of the sides, including these angles, are proportional, then the two triangles are similar. So then, if we know that this side and this side are proportional to this side and this side, which once again, just like congruency, this angle has to be the angle in between those two sides, then we can say for certain that the two triangles are similar. So what we're going to do now is we're going to look at quite a few examples. So we're going to look at some just straight math examples, and then we have two kind of more real-world examples that I'm actually going to have you work through on your own and check your answers with me. Okay, so let's look at these two right here. Are the triangles similar? Well, in order for them to be similar, we need to know that either SSS, all three sides are proportional, or SAS, two of the sides are proportional, and the included angle. Okay, so here's what we know. We know that AE is 4, and if we're setting up a proportion, AE in the smaller triangle would correspond to AC. So AE over AC would have to be equal to AD over AB, because those two sides are corresponding as well. You can see we don't know anything about this side, and since we don't know anything about these two sides, we don't know whether they are going to be proportional to these other two sides, so we definitely can't use side proportionality. We definitely can't use it because we don't know either the lengths of the third side. But we still could use SAS similarity. And why? Well, look at this angle here. Is the included angle between this side and this side going to be congruent between the two triangles? I hope you're saying yes. Why? Because this angle is going to be the same in both of these triangles. So that angle is clearly congruent. So we already have this angle part checked off. And if we can say that these two sides are proportional, then we can use SAS similarity to say that these two triangles are similar. So let's plug in what we know. Okay, so I'm going to do that here. So I'll do it in green. So 4 is AE. What is AC? AC is this whole side, so that would be 4 plus 12. So 4 over 16 is going to be equal to, we need to see if that's equal to 5 over 20. Well, let's see what both of these reduce to. 4 over 16 reduces to 1 over 4, and 5 over 20 reduces to 1 over 4. So look at that. Those sides are proportional, and that means by SAS similarity, we can say yes, these two triangles are similar. So what we're originally given will kind of determine the path that we will go. So if we're originally given links for two sides of each triangle, then we're probably going to use SAS. If we're originally given links for all three of the sides of the triangle, we're probably going to use SSS. So let's look at this one. Are the two triangles similar? So we know a lot of the same information. We're either going to be using SSS similarity or SAS similarity. And we know that if either of these are going to be true, we need these sides to be proportional. So let's go ahead and set up a proportion. This is just the same as in the last problem. So we know that one was 4/16. That's going to have to be equal to this side over this side, which is 5/15. Well, 4/16 is 1/4, and 1/15 is 1/3. So right away, we can see these sides are not proportional. So that means that these triangles are not similar. So no, these triangles are not similar. Let's look at one more. Are these two triangles similar? And then we're given that this side right here is parallel to this side. Well, how does that help us? Well, that actually helps us a lot, because since these are similar, we know, based on our rules about parallel lines, that this angle and this angle have to be congruent. Remember, those are corresponding angles, and when we have parallel lines cut by a transversal, the corresponding angles are going to be congruent. And similarly, we know that this angle will be congruent to this angle. And by AA similarity, we know that that's all that we need to know in order to say that two triangles are congruent. So you can see that now you have three tools in your tool belt to prove that two triangles are similar. I'm sorry, I just misspoke a second ago. These two triangles are similar, not congruent. So you have AA similarity, you have side similarity, which says that all three sides are proportional, and you have side similarity, which says that two sides are proportional and the included angle is congruent. So what I want you to do now is we have two real-world problems. And what I want you to do now is I want you to take a try at each of them. These are hard problems, and that's okay, but I want you to try and figure out and answer and solve these problems. And then when you're done, come and check your answers with me.